Hi, I'm Bailey with My Math Experts, and today I'm going to show you how to solve this problem. Find the slope of the line that passes through the point 47 and the point 13. So slope is the measure of how steep or not steep a line is, and it is defined as change in y values divided by change in x values. So with coordinate points, a way that you can write that is y2 minus y1 divided by x2 minus x1. So this might look a little intimidating. You might be like, why are there all these subscripts? Why are some of them ones? Why are some of them twos? What does this mean? It's actually not that bad. All it means is x1, for example, is the x value of your first coordinate point. X2 is the x value of your second coordinate point. Y1 is the y value of your first coordinate point. And y2 is the y value of your second coordinate point. It doesn't matter, by the way, what you choose as your first coordinate point or your second coordinate point. All that matters is that you're consistent, so that x1 and y1 are together and x2 and y2 are together. And of course, just as a reminder, coordinate points are always written as x comma y. So you want to make sure your x's are first and your y's are second. And then I always recommend labeling just like this, labeling what x1, y1, x2, y2 are, so that then it's really easy to just plug these numbers into the formula. So we can see our y2 is 3, our y1 is 7, divided by our x2 is 1, our x1 is 4, and then we just simplify this. So 3 minus 7 is negative 4, 1 minus 4 is negative 3, and then we can actually simplify this even further because we have negative 4 divided by negative 3, that simplifies to positive 4/3 because a negative divided by a negative is a positive. So that is your slope. We can also see this on a graph if you want. I recommend doing this approach first, but you can use a graph to check. The reason I don't recommend doing a graph first is that if you have some really big, crazy coordinate points, like 1 million, 7, that is not going to be easy to graph, but it is much easier to work with this formula for stuff like that. But we can check on a graph here. We can plot our points. So one of our points is 1, 3. One of our points is 4, 7. And another way that you can think about this formula is rise over run. So we can see we're going, if we just connect these points, we can see our line. So our line is going to look something like this. And we can see we're going up 1, 2, 3, 4 units, over to the right, 1, 2, 3 units. And so we're rising up by 4. We're running over by 3. We again get 4 divided by 3. So a couple of different ways you can figure this out. The interpretation of this, by the way, I'll put interpretation over here. A perfectly 45-degree angle, a perfectly diagonal line, has a slope of 1. So ours is a little bit more than 1. It's 4 over 3, so a slope of 1 would be 3 over 3. So ours is a little bit steeper. A little steeper than 45 degrees. And likewise, if we had something that was like 1/2 or lower than 1, between 0 and 1, that would mean that it is less steep than 45 degrees. So ours is a little bit steeper because it's a little bit over 1, which is perfectly diagonal. Great. Thanks for listening. Hope this helped.